This session is covering some collaborative research with CSIRO and Angus Australia in an innovative space around ImmuneDEX. Before I go and talk more about ImmuneDEX, what's important is to understand the importance of health in a beef system and the beef supply chain. Obviously, when there's health challenges, it adds costs into the system, whether that's loss of production or costs of additional treatments for those animals. And two examples of that in diseases that affect Angus cattle, particularly things like BRD, bovine respiratory disease, in feedlots is expected to cost predicted to cost the industry about $40 million per annum, or something like pink eye affects the industry around $23 million per annum. Some initial work out of this research also found that generally only a small group of animals within a group really make up a large amount of that feed costs and health costs. Sorry, so basically health treatments and health costs have a big impact on the system. So what can we do about that? Obviously, the other thing in this space is the consumers are becoming more and more aware of the use of things like antibiotics in treating animals and in those side of things. So anything we can do to try and reduce reliance on those things for the consumer's acceptance is pretty important. And ImmuneDEX in this work really allows Angus breeders to be really proactive rather than reactive to health issues, particularly through selection and genetics. ImmuneDEX, to get a bit more detail on this particular project, is a collaboration between Angus Australia and CSIRO. It's led by Dr. Brad Hine, who's done a lot of work in the immune response area across a lot of livestock, but particularly now working a lot in cattle and in the Angus cattle. And it really builds on the work of our Angus CSIRO benchmarking program to collect immune competence and immune phenotypes on those cattle, and allows us to research and produce new information like ImmuneDEX. Immune response is something to think about and to appreciate. Is it really can go down a number of streams of how immune response happens. It's quite a complicated thing looking at immune systems and immune responses. But in the end, what we're trying to do here is measure animals' overall immune strength, the strength of their immune system. And a way to think of that is the best immune system is not the one that's the strongest, but the one that really maximises fitness in a lot of constraints. And that's why, as we'll talk about more in a minute, we measure immune competence on cattle when they're under stress, particularly at weaning. So as we know, when people stress or when an animal's stressed, they can display their immune systems in a bit more spread, so they could be affected by diseases or not. So that's why we like to measure this particular trait when they're under stress, and they're under stress generally when they're being weaned. That's quite a stressful event for cattle, so that's why we focus on that. So basically how we record it, the first thing to understand, this is a really hard to measure trait. We talk about hard to measure traits all the time, but this is a hard one to measure, and that's why we do it through our research programs like the CSIRO benchmarking. And we assess two streams of the immune system, the immune competence. The first is the antibody-mediated response, which is done through a blood test. And the second one is cell-mediated immune response, which is basically a skin reaction test, which I'll talk more about in a second. But it's really our traits as breeders, as Angus general recorded breeders. You probably wouldn't go out and do yourself. You rely on research and a reference population to make access to that. In a bit more detail about what the recording protocols are. As you can see here, pre-weaning, we vaccinate the cattle with a Clostridial 7-in-1. What we do then is at day of weaning, we then wean them, weigh them, crush score them, vaccinate them again with 7-in-1 to give them that booster. We do a flight speed test for temperament, and we collect a blood sample as well. About day 12, we then inject for the skin testing, and we weigh again. And then day 14, about 48 hours later, we collect another blood sample. We measure the skin test, so this is basically the caudal fold of the tail. We inject 0.1 of a mil of 7-in-1 in on day 12. Day 14 we come back and we measure how big that lump is. Animals with generally a stronger cell-mediated response have a larger lump. And then we do some docility and flight speed recording again. So quite intensive sort of recording, but important to do in this case. So where we're up to with this recording is we've collected phenotypes for immune competence in the ASBP on approximately 3,000 steers and heifers at weaning. That represents 165 sires across cohorts 2 and 3, 6 and 7, And we've also just got the data for cohort 8, which we'll talk about later on. And they're being used to calculate research breeding values, which we'll go into more detail in the next slides. So based on the data collected on immune competence, primarily through the ASBP, we've been able to do some initial genetic evaluation work, calculating the heritabilities of the traits, and as you can see there, 0.23 and 0.28, which is similar to what we see in our growth weight traits, which means we can make genetic gain on those if we want to select on them. In regards to genetic correlations with other traits, we're sort of a bit limited on data at this stage, but what it's indicating at this point is there's a slight negative correlation between the production traits and immune competence, particularly with the growth and ImmuneDEX area trait. Relationship's only weak. This is consistent with what we see in other livestock species. High production, slightly lower immune response. The other thing from this research we find is animals with genetically better temperaments will have stronger immune systems on a genetic correlation basis, but that relationship is also weak. So we just need some more data to shore up those genetic correlations, which is what we're working on. So based on that, we've been able to calculate our ImmuneDEX value, which is basically our genomic breeding value. So we don't actually use pedigree, we're basing it all on our genomic relationships and the phenotypes performance data collected through this program. And really what this value does is provides an estimate of animals' genetic differences, so side differences, for example, on a genetic level for their overall immune competence. So basically higher ImmuneDEX values, which takes into account both antibody and cell-mediated response combined into the one index for immunity, ImmuneDEX. To look at animals with a higher ImmuneDEX gives us a higher number of progeny with stronger immune systems and therefore reduced disease incidence overall. That's how we interpret it. Based on that, you can see this is a list of the top 20 sires. We've got a list of 165 sires we can access. This is the top 25 out of that list, where we've got the animals identifiers there, which cohort they've come from, the sire benchmarking, the research breeding value for ImmuneDEX, the accuracy based on the number of progeny measured and the relationship with other animals, and giving us the ImmuneDEX value, which you can have a look at. So to interpret that, what we see is there's a significant range. So the ImmuneDEX values range from 70 to 0. So we've got significant range in the immune response. So if you want to incorporate these in your breeding program, you could actually select animals that have high immune response, but it should be single trait selected, should be looked in conjunction with all the other performance traits as well, calving ease, growth, carcass traits, etc. So have a look at those. But just be aware that we're still in research breeding value space, so things could change as we change models and we get more data. And we're obviously limited to the ASBP size at this stage, so we haven't got a large list of size. That sort of limit things a bit, but that's the situation we're in. In regards to, if we look at ImmuneDEX, as you can see, there's a bit of a scattergun approach there when you look at the relationship between ImmuneDEX down the x-axis and the Angus breeding index, which doesn't include immune competence, but just their standard Angus breeding index on the y-axis. You can see there, you can still find animals that have high ImmuneDEX values, but also high ABI values, and they're the ones we should be looking at in regards to selection going forward. If you want to access the full list of animals, you go to the Angus Australia website, and under the research tab you can find the full listing of the 165 sires. When we update the list, that's where it'll be as well, so just be aware of that. So what's the future of ImmuneDEX hold? Well, first of all, we'll continue to collect our immune competence phenotypes as part of the Angus sire benchmarking program. We've built that into that program now, so that'll be continue to record that. Obviously more data will improve the accuracy of our research breeding values and hopefully allow us to move across to full production breeding values at some stage soon. In the shorter term, we've got the cohort 8 immune competence data collected and analysed. We just need to put, when I say analyse, back from the lab, we do need to then put that in the mix with all the other data to update our research breeding values and include the cohort 8 sires. So that's what we're looking to do the first quarter of next year, 2020. Obviously a key thing for this though is to continue to look at the validation stage. So ImmuneDEX is quite a nifty thing to look at, but how does it actually relate to things like BRD incidents, pink eye, other disease incidents? And there is a large project particularly looking at risk in feedlots and lining up ImmuneDEX, immune competence traits, with the health issues in feedlots to give us some more data on how this can be applied and what the expectations are of the outcomes if you select on it. And importantly for industry and for our members, we're also looking to set up a pipeline. So if you genomically test an animal with Angus Australia for genetic evaluation, so on one of the high density profiles greater than 5,000 SNPs, for example, like our Angus GS or Angus HD50K product, we're looking to produce ImmuneDEX values in all those animals because we have got a reference population of that set up now. So that's the next step as well. Now, if you're interested and you're a bit more scientifically minded, you can also access the paper on this initial work in this program from the journal Animal Science, and the information's there for you to find that paper. So it's recently published, so it's been peer reviewed, and obviously it's a bit of science with a lot of credibility to it. So that's may be of interest to